Hello everyone, good to see all of you. So today I'll be sharing with you how you can convert decimal to binary. So just a disclaimer first, whatever I'm sharing with you is based on my understanding on the subject itself. So I will try to explain as accurately as possible. So if you are ready, let's get into it. So first, I always feel that before you learn anything, you're going to know why we are learning this. As you all know, this channel is all about ethical hacking. So as a hacker itself, you should know basic fundamental knowledge on the networking system. So in networking, there's this thing called the IP address. So as you can see here, this is the IP address. So there are some unique features on the IP address which I would like to share with all of you. So first is IPv4 version 4. So there's also something called IPv6, which I will not go into it today. I'll talk about it in the next video. So basically, IP address is like your house address. If let's say your friend want to send something to you, they want to know where your house address is so that they can send the parcel directly to you. So in the digital world, people got to know where your router is. And the router is the one that receives the information or the data. So if let's say someone wants to send an email, they must know send to which email address and which IP address that you can receive this email. So in this case, I will take it as this is your digital world address. One thing about this IP address is it's 32-bit long, so it can support up to 2 power of the 2 IP addresses. So in total, about 4.2 billion IP addresses, which is a lot of IP addresses. And if you see that each value itself is actually represented by 8-bit, which I will explain later. And each value that you can see here is the maximum value can go to is 255. Why? Because it's based on the base 2 numeral system. And the base 2 numeral system, as you can see at the bottom, is a 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, and total is equal to 255. So the maximum value can go to is 255. So that's what you need to know about the IP address. So in this video, I'll not talk about much about IP address. I will talk about how you can convert this IP address to binary. And why do we need to convert the binary? Because as a human, we recognize all these numbers, but for machine, they recognize the binaries. So what are binary numbers? So you can see here, binary numbers are 0 and 1. So there's only these two states, 0 or 1. That's why it's called binary. So this is a machine language. So machine understand binaries. So when we look at the IP address, it needs to be converted to binaries so that the machine can understand and process it. So 1, you can see is 1 bit. 0, there is also 1 bit. So you can see this is 2 bits. And this binary system is also reconstructed in a way that it can represent a lot of more numbers. Because since machine can only recognize 0 and 1, it need to follow a system whereby it can represent more than 0 and 1, right? So that's why we have this base 2 numeral system. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. And if you do a calculation, 2 power 0 equal to 1, 2 power 1 equal to 2, 2 power 2 equal to 4, 2 power 3 equal to 8, and 2 power 4 equal to 16, 2 power 5 equal to 32, 2 power 6 equals 64, 2 power 7 equals to 128. So when machine wants to process certain numbers, they will represent in this base 2, they'll follow this base 2 numeral system. And which is important because you need this to convert the decimal to binary. So let's give you an example. So if let's say you want to convert the decimal 192 to a binary, how can you do it? So first you have to write down all the base 2 numeral system, which is 1, 2, 4, 8, 16, 32, 64, and 128. So first, you do a try and error. So you see, decimal 192, right? So you try 128 because 128 is smaller than 192. So you take 192 plus 64. And what does it give you? 128 plus 64 equals to 192. And there you have it. You got your answer. As simple as that. So you add up those numbers that is represented as 1. So in this case, 1 is the most important one. The rest can fill up as 0. And the answer is 1100 and 0000. So you can see here, it's actually 8-bit long. So you can see here there are 8 digits in the binary. So that's why, just now I mentioned earlier on, is the 8-bit long for each number that's in the IPv4 address. Next, give you another example, which is decimal 244. So once again, you use a 128 plus 64. Just to give you a try, you see 192. It's still smaller than 244. Let's add 32, and you get 224. Still smaller than 244, and you add 16. It goes to 240. Now we are very close. So can we add 8? But we add 8, then it becomes 248, which is more than 244, which is not the answer that we want. So we skip 8, then we go to 4. So 240 plus 4 equals to 244. So once again, we put all the ones at the bottom and the numbers that we want. So we add it all up. And of course, you have to fill up the rest with zeros. And the answer is 11110100. As simple as that. So if you find that the previous method is a bit slow, you might be thinking, is there a better way, or is there a quicker way to solve this problem? There is, or I mean, at least I think that is quicker. And I also want to say here is that the method that I'm going to show you is not invented by me. I was doing some research and I saw some YouTube video and I thought that's pretty cool. That's why I adopted his method. So I'll also put a link down in my description section below, so you can take a look to find out more. So first, you put the 244 at the first position. Then you divide by 2, equal to 122. Then you divide by 2, equals to 61. You divide by 2 again, it's actually 30.5. But you ignore the remainder, you just take the numerator. So it's leave it as 30. Divide by 2, 15. Divide by 2 is actually 7.5. Ignore the remainder, put as 7. Divide by 2, 3, ignore the remainder, and ultimately becomes 1. Next, what you need to do is, those that are odd number, you put as 1. Even number, you put as 0. So you can see here, I've already put all the odd number as 1, the rest put as 0. And the answer is 1111 and 0100. There you have it. So you can also double check your answer, which is 128 plus 64 plus 32 plus 16 plus 4 equals to 244. So that's it for this tutorial. So if you find that this method is useful, definitely let me know in the comment section below. Or if you find that there are better ways to solve this, let me know as well. And I'll be happy to learn more about it. If you like this video, I'll appreciate if you can give a thumbs up and subscribe to my channel. And I will see you in the next video.